This is a HCl molecule. Now this is called a molecule. Combination of two atoms staying together. And the total charge of HCl is H is positive, Cl is negative.
0.
What is the total charge of HCl?
0.
0. Here it was total charge 1 positive, here it was total charge 1 negative. They both combined. So it is 0. Total charge of HCl is 0. So this is an, you can say, hydrogen element, chlorine element got together to form a compound which is known as HCl. This is a molecule, HCl molecule.
So in our stomach that is only there.
So this is known as hydrochloric acid. This particular compound is hydrochloric acid. Understood? Similarly, there is another such compound, NaCl. NaCl, which is made up of Na positive and Cl negative. Both together forms NaCl. This is salt, which we eat, common salt. Na is sodium. This is sodium. And this is chlorine.
What is chlorine?
It's a type of compound. It's a type of element. Like hydrogen is an element, helium is an element, gold is an element, silver is an element, iron is an element, uranium is an element. Similarly, sodium is an element and chlorine is an element.
How many atoms are solid? How many these electrons and protons? In sodium.
Sodium. We have to check. I don't know.
And
They are solid
Sodium
like gold,
is metal.
gold and silver. They are solid. This chlorine and sodium, they are solid particles.
The properties depend. At room temperature, what is their property will depend on number of electrons they have and all these different categories. So that we will study in this periodic table. So sodium is 10, 11. 11 is the sodium. Sodium's total number of electrons are 11. So 2, 8 and 1. So 1 it will give away and chlorine will take 1. That's it. Understood?
11. So 2 is. And chlorine? How many?
Chlorine has 17. So 2, 8, 7. So if it takes 1, its 8 is finished. This one will lose 1, its 8 is finished.
Sodium has 10.
Sodium has 10, 11.
11.
11.
If it has 10, then it is stable. 2 and 8, that's it.
Then no mixing will be.
Yeah. So the elements or atoms which have in their natural state, their outermost orbit full, they are called inert elements. Inert means it will not react with anyone. It will just remain. Noble gases. They are called noble gases. Noble means साधु जो किसी के साथ झगड़ा नहीं करते. So these are these noble gases. Helium is a noble gas. It has 2 electrons. Then neon is a noble gas. Neon lights we see. Neon is a noble gas. 2 and 8. These all noble elements are in the form of gases. Argon is a noble gas. 2,
Carbon.
8, 8. Argon.
How many?
Argon. 18. So 2, 8, 8. Then 36 krypton is another. 2, 8, 18, 8. And xenon. 2, 8, 18, 18, 8. And radon. 86. So like this. Understood?
Hey, but uranium?
Iron is the biggest.
Uranium?
Uranium is a metal. It will react.
It will react.
It is 235. 92. Okay.
Hold on, baby. How we can
Now how many electrons are there in uranium?
If proton, it will find proton. Means how much it will be electron. In uranium, means like this we can find this electron, that how many protons will be there, that many electrons will be there. Then
Either how many electrons are there, you can also find like that. There are methods to do
means
it.
in
I don't know.
uranium means how we can find this.
There are methods to do that. I don't know about them. What are the experiments by which you ensure that these many electrons are there in this particular unit? Okay. So this is fundamentals of chemistry or elements.
Prabhuji,
So now there are many scientists who are researching for thousands or you can say many decades to come to this periodic table which enlists about 108 elements.
Yeah, 108.
Depend so
In this
how much is the electron numbers or the atomic number. So and they have placed them in a particular order in the form of a table, because as we saw that how much is the valency in the outermost orbit, that means how many number of electrons are there in the outermost orbit, depending on that it will react with other atoms. Any atom will react with other atoms. So that means the properties, majority of the properties, chemical properties of an element, chemical properties of an element means that its properties to react with other elements to form different types of compounds. Compound मतलब एक element से ज़्यादा प्रकार के element मिलकर के जो बनाते हैं substance compound कहते हैं. To form a compound, this is chemical property of an element. So it depends on the number of electrons in the outside valence orbit. So that means those elements which are having same number of electrons in the outside orbit will have similar properties. Correct? Say fluorine, it is denoted by F. Its atomic number is 11. While chlorine, atomic number is 17. Both will have 7 electrons in the valence orbit. Correct?
Huh?
One.
7 electrons.
Fluorine, one will be there. Because 10.
Sorry, fluorine is 9. Okay? Both will have 7 electrons. So fluorine and chlorine will have similar properties. When it will come in contact with hydrogen, then it will form hydrogen fluoride. When chlorine will come, then it will form hydrogen chloride, like this. Both will be accepting 1 electron,
From hydrogen.
either from hydrogen or whatever substance are coming. So chemical properties are similar. So they make one column. This whole table is there. So they have this whole table. In that there will be columns. Okay. So in the column they will put such in one column. This will be number of valence electrons. So say this is 7 electron. Then fluorine is there, chlorine is there, bromium is there, bromine is there. And iodine is there. So like this, all this will be in the same column. Okay? Are you able to understand?
This is outside orbit.
Outside number of electrons is 7.
All
They will be kept in the same column. And the one which has more number of orbit will be in the ascending order. Means fluorine will have say 2 orbits, then chlorine will have 3 orbits, bromine will have 4 orbits, like that. So they will be in the descending order, kept in the descending order. Okay? So this way the whole table is made. and that is called periodic table. So by arranging in this way, we can group similar properties materials, similar property elements together and understand that how they will react with others. So it becomes easy to analyze chemicals or elements chemically. Correct? So this is what is periodic table.
Kshama, if there will be 7, there is one atom is it is around that electrons are how many is outside orbit there is 6, and
So it will take 2
And-
electrons from another.
and if there will be another atom if they outside orbit if there will be 7, then what will happen? 7.
I have just explained you about the ionic bond only. This is one kind of bond. In this is called ionic bond. And this a substance completely loses one atom completely loses its electron to other atom. This is ionic bond. One becomes positive, one becomes negative, and there is a bond. But it may not always be the case. Say for example oxygen. So I spoke about ionic bond. Now we will spoke about the covalent bond. So say oxygen is there. So oxygen is having 6 electrons in its outermost orbital. It's 8. Atomic number is 8. Oxygen atomic number is 8. So here 8 positive. So 2 electrons here and 6 electrons in the outermost orbital. Now oxygen is available in the form of gas, pure gas, means oxygen is there. So what it does, this is one oxygen atom and this is another oxygen atom. Okay, 8 positive, 2 negative, and 6 negative. Okay, what oxygen does, it shares 2 electrons. It shares its electrons and it makes O2.
Two oxygen shares.
2 oxygen atoms share the electrons.
Shares how? Means they don't have 2 electrons, means they have less. Means this outside orbit there is means there are 2 electrons are less. So how will they will share this?
They will share each electron. Say for example hydrogen is also doing that, oxygen is also doing that. So that is called covalent bond. How they will share? How much they will have to share? 4, 4. 2 electrons they will share.
Each. Because the hydrogen.
So 4 individual electrons and 4 shared electrons. So there will be 2 bonds. Double covalent bond. Understood? This is 8 electrons of this oxygen and this is 8 electrons of this oxygen. 4 are shared, 4 it has, 4 it has. So this is called shared 1 electron, this is 1 bond and this is second bond. So double covalent bond is there. So these electrons will be shared by them and that's why they are together. So it remains as O2, oxygen 2. It is never formed as single O. Similarly with hydrogen. Hydrogen is 1 electron is there, so both the electrons are shared by 2 hydrogen atoms and that's why hydrogen is also available as H2. Similarly nitrogen is also available as gas form as N2.
What is carbon dioxide?
Carbon dioxide. Carbon has 4 electrons. Carbon dioxide is ionic bond? I don't know. Carbon has 4 electrons in the valence orbit. Correct? carbon, yeah, 2, 4, 6 is the atomic number. So 2. Carbon is a very specific atom actually. Because of its this atomic number, it can react with wide varieties of elements. And thus carbon is found in nature with so many different type of compounds, and long chains it can form like this. So 6 electrons. Sorry, 4 electrons.
4.
Oxygen has in the valence orbit 6 electrons. Another oxygen has in the valence orbit 6 electrons. So carbon will give its 2 electrons here and 2 electrons here. Make both of them O2 positive, O2 positive, O2 negative, O2 negative, and C4 positive.
Means then this oxygen will separate, means
Yes, it will be there only because positive charge is there. Oxygen has negative charge, carbon has positive charge. So bond is there. So bond is always there, but the electron now belong to oxygen, not the carbon. Carbon has only
so they cannot be separated.
because positive charge is there. So by that attraction they will be together.
Oh, one has positive and one has
Negative.
negative. Oh.
And in the covalent bond they are sharing the electrons. That's why they are together. So ionic bonds are more strong because it has electric force, electromagnetic force holding them together. Covalent bonds are not so strong as ionic bonds because they are just for the reason that the outer orbit, if they have 8 electrons, that orbit is more stable. For that reason they are sharing the electrons. So now you understand covalent bond also. All the gases which exist in pure form like nitrogen, oxygen, hydrogen, means there is no other atom inside them. So they are existing in covalent bonds.
Sharing.
Always.
They are sharing.
Always sharing, because if both same atom are there, both or 3 of the same atoms are there, they cannot give one electron to other because other is also in the same way. If hydrogen atom it needs one electron, then another hydrogen atom will also need one electron. So they both share. So H2 we find, N2 we find, O2 we
N2,
find.
what is N2?
Nitrogen.
How many?
2 atoms will be there.
2 atoms.
Yeah, 2 atoms together will form a covalent bond.
Means how many in one atom?
Electrons.
No. Ah.
Okay. કાલ મોકલેલા તેમ જ મોકલી દો. મોટા ને કાલ નથી ને બોલતા તો 3 ને મોકલેલા. એ તો ઉપર જવાનું હતું ત્યારે. હમણાં હતા ને. લોટ બાંધતા તો નહીં આવડે. વણતા આવડે છે મશીન.
कैसे है तो माता जी से
તો એ 3 ને જ મોકલું છું. 12 વાગે સચિદાન તું લેક્ચર દેતો. સવારે
आज कौन से
હા કાલ રાત 2 દિવસ.
चले नोज नेक्स्ट
What?
थ्री
I will stay. You or he will stay.
Like this.
Pressure will come.
Sweater.
Okay, so now we will see one video 20 minutes. on the periodic table. These are
It will not, I will come here, that's why.
In this video, we're going to focus on chemistry. We're going to go over some of the basic topics that you need to know if you're about to take a course in chemistry.
3 hours?
So let's begin. Let's start with the periodic table. So you need to know the names of the elements, the groups, and some of their properties. So in the first column, you have H, which represents hydrogen, and then lithium, sodium, potassium, rubidium. Now, hydrogen is a nonmetal.
Are you able to
But the
understand?
other ones
First
below
column.
that, the lithium, sodium,
Periodic table.
potassium, rubidium, and even cesium, those are known as alkali metals. The alkali metals are the most reactive of the metals in the periodic table. If you, let's say, put sodium in water, it will react violently. And now, the elements in this row, they all have one valence electron. Therefore, they like to form ions with +1 charges. Now, in the next column, we have elements such as beryllium, magnesium, calcium, strontium, barium. These are known as the alkaline earth metals. These metals are reactive.
One electron
Each.
in the valence orbit, last orbit.
Submit.
So that will tend to lose one electron and thus form positive charge. This is the indication of hydrogen ion, lithium ion. Its ion will form positive.
Active as well, but they don't react as violently as the alkali metals. Now, the alkali earth metals, they have 2 valence electrons. The valence electrons are those electrons that are in the outermost energy level of an atom. The inner electrons are known as the core electrons. The alkali earth metals, they like to form
What is +2 minus 2e minus
2 electron. In the outermost orbit, it has 2 electrons.
ions with a +2 charge. Metals, they like to give away electrons. As they release electrons, they will form
Here helium is not involved because helium has only one orbit. So 2 electrons means it will be stable. So it has gone back in the stable gases.
a positively charged ion known as a cation.
This is beryllium, magnesium, calcium, strontium, barium.
The vertical columns are known as groups in the periodic table.
So in the periodic table, vertical columns, these are groups. These are known as groups. And these are known as periods, the rows.
So the alkali metals is group 1A. The alkali earth metals is group 2A.
So 1A is alkaline metals, they are called. 2A is called alkaline earth metals. Go quick.
The rows are the period. This is period 1, period 2, period 3, and so forth. And next to potassium and calcium, you have the transition metals. You have scandium, titanium.
This is speaking about showed these two, then he's speaking about these. These are called transition metals, and these are non-metals. Means this is the third. These are called transition elements. These are alkaline earth elements. Then these are there. Then these are there. So he's showing that.
Vanadium, chromium, manganese, iron,
Iron is denoted by Fe.
cobalt, nickel,
Ferrillium is its name.
copper, and zinc. Below copper, you
Copper
have
is Cu.
silver
Zn is
and
zinc.
gold. Below zinc,
Silver is Ag. Au is gold.
you have cadmium and mercury. Mercury is Hg.
Hg is
Next
mercury.
to silver, you have palladium and platinum. These are some common elements that you want to know the name of. Now, the transition metals, they have variable charges. At least most of them do. For example, iron can be in the +2 or +3 oxidation state. Copper is typically +1 or +2. So they have variable charges. But some of the transition metals like zinc have a common charge of +2. 99% of the time, zinc has a charge of +2. Same is true for cadmium. Silver is usually +1. Gold can be
What does this show? That iron, it is found in natural in elements, in compounds. Either sometimes it will have lost 2 electrons, sometimes it will have lost 3 electrons. So either it will be in +2 form or +3 form. Copper is also +1 or +2 form. So majority in the transition elements, majority are found with more than one type of ions. They may be losing 2 electrons or 1 electron or 3 electron. Except zinc.
+1 or +3. Mercury could be +1 or +2. So you need to know the charges of some of these ions. Cobalt is usually between +2 and +3. Manganese could vary from +2 to +7. Chromium, typically as a monatomic ion, +2 and +3. So those are the transition metals. So let's say this is the transition metal area. Over here you have group 1 and group 2.
1A, 2A.
And then in this region you have the inner transition metals.
This is 1A, 2A. These
The top
transition
part
metals.
is known as the lanthanides.
This is some other small categories,
And
and there will be
below
big
that.
category here.
Represents the actinides. And then you have the elements on this side,
These are
which we're about to go over. So groups 1 to 2A,
these cell elements are these. These were like actinides and those which were shown.
Lactanide series, actinide series.
Okay.
and groups 13 to 18, these are known as representative elements.
These are 13 to 18 group.
Group 3 to 12
These are 3
is
to
the
12
transition metals.
transition metals. Correct?
3 to 12, 13 to 18,
Understood?
and 37 to
And then this is the inner transition metals, which are non-representative elements. Now let's focus on groups 13 to 18.
Which was there on the
Group 13 is
this
also
side
known
it was
as Group 3A. And the elements in this group are boron, aluminum, gallium, indium, and thallium.
there. This 3A is 13 actually. There are two nomenclatures 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Okay? And then 3B, 4B, 5B, 6B, 7B, 8 like this. And another is 1, 2, 3, 4, 5, 6, 7, 8, 9, 13 to 18. Okay? So this 3A is written for that, not that this is group 3.
Next to boron, you have carbon, and below that,
So
silicon.
3A has boron, aluminium, gallium, I don't know, iron,
Indian something.
indium,
Indium.
and TL also I don't know. These will have
helium.
5 means 3 valence electrons.
Germanium, tin, and lead. This is group 4A. The group 3A elements, they have 3 valence electrons.
Okay?
And most of them like to form +3 charges. For example, aluminum likes to form a +3 charge ion. Same is true for gallium. But gallium, I've seen the +1 and +3 state. For indium, it can be +1 or +3. And the same is true for thallium. But aluminum usually doesn't form the +1 ion. It's, for the most part, +3. Now, for the group 4 elements,
So what about B?
silicon, for example, can have
What about B?
What about?
That B means they spoke about aluminum, they spoke, and
Boron. That will also.
a +2